Hey guys, in this video we are going to go over page 34, solving systems of linear equations by graphing. You can go ahead and pause the video and tape down the page for page 34. It's going to be front and back. So we're going to go ahead and get started with the front of the page. So there's a fill in the blank. A system of equations is two or more equations. So the blanks that you are filling in is a system of equations is two or more equations. That's the definition of a system of linear equations. A solution is the coordinate x comma y that makes all equations true. It's also the intersection point. So that's one thing to know about the solution. So you're filling in the blanks. A solution is the coordinate x, y that makes all the equations true, which is also called the intersection point. So now we have to talk about the types of solutions. There's three different types of solutions. So we have a graph that looks like this, where it's crossing one time. So go ahead and put a point right there where the two lines cross. This means that there is one solution because there is one intersection point. So however many times the graphs intersect, that's how many solutions you have. The next scenario are two lines that look like this. Those lines never actually touch. That's called parallel. So when the lines are parallel, they never touch, which means there is no solution. Because the graphs never touch, so they never actually intersect, so they don't have any solution. And then the last scenario is one single graph that looks like this, but there's another graph that's hidden underneath of it. It's two graphs overlapped on top of each other. That means that every point on the graph is a solution, so there are infinitely many solutions. All the points on the graphs are solutions. So when we have overlapping lines, technically there's two lines there. That means there's infinitely many solutions. So those are the three different types of solutions that we'll see today. All right, so go ahead and flip it over onto the back. We're going to go over the example of solving the equations by graphing. So you'll see that there are four different steps on your half sheet. So 1, solve the equation for y. Graph both equations on the same graph. The intersection points of the line is the solution to the system, and write your order pair. So step 1, we have the equation x plus y is equal to 1. And then the other equation is 2x minus y is equal to 4. So step 1, we are going to graph the equations in Desmos. So we're going to open up a Desmos graphing calculator. We're going to type in x plus y equals 1 and 2x minus y equals 4. So we're going to draw those two graphs. So I have one graph looks like this. The other graph looks like this. All right, so that was step 2. Graph them in Desmos. Step 3, the intersection point. So step 3, here's our intersection point. So step 3, find intersection point. I found the intersection point. So now step 4, write your answer as an ordered pair. So if we click on the solution in Desmos, we see that the solution is 1.67 if we round it, and then the y value of the solution is negative 0.67. And that is your solution. So there's one solution, and it is the coordinate 1.67 comma 0.67. That is where my two lines intersect. So I'm going to have you pause the video, finish up page 34 notes if you need to review any of the steps or the different types of solutions, and then I will go ahead and give you the practice that goes along with page 34 notes.